I'm Katie McCullough from the Education Institute team. In this video, I will show how decimals extend the base 10 place value system in order to express values that lie in between whole numbers. Decimals can be written as fractions and fractions can be written as decimals. So please be sure to watch Intro to Fractions for more information about fractions. When you get change back from a grocery store, the amount is often less than one whole dollar. You may get 53 cents or 27 cents or 5 cents. These amounts of money have some value, but their value is less than one whole dollar. So let's take a look at how we could visualize the sizes of numbers like these. Let's take a look at the space between 0 and 1 on a number line, which in this case would represent amounts of money in between 0 and one whole dollar. There are 100 cents in $1. So if I cut this space into 10 equal pieces, each section represents 10 cents or 1 dime. Because we split this space into 10 equal-sized pieces, each section also represents 1/10 of the space between 0 and 1. So I can also represent this as 1/10. I can write that as 1 over 10 or as 0.1. If I have 53 cents, I know that's more than 50 cents or 5/10 and less than 60 cents or 6/10. 53 cents would be closer to 50 cents than 60 cents, but to make sense of exactly what this means, I need to zoom in and visualize each cent in between 50 and 60 cents. There are 10 cents in between 50 and 60 cents, so I can split the space on my number line between 5/10 and 6/10 into 10. This helps me find where 53 cents should land exactly on my number line. Because there are 100 cents in a dollar, when I mark each individual cent like this, each section represents 1/100th of a dollar, or 1/100th of the space between 0 and 1, which can be written as 0.01. Continuing to think of these numbers as coins can also help me see that there are multiple ways to visualize values like this. 53 cents could be 53 pennies, but it could also be 5 dimes and 3 pennies. That's because 10 pennies will always have the same value as 1 dime. Each penny represents 1/100th of a dollar. And when we have 10 100ths, that's the same as having 1/10. So 10 hundredths is equal to 1/10. Just like I can think of amounts of money in terms of different groups of coins, I can think of decimals in terms of different place values. 0.53 can be thought of as 53 hundredths or as 5/10 and 300ths. Let's look at another more complex example, 3 and 158 thousandths. I know that this value lies in between 3 and 4, but is much closer to 3 than 4. In fact, it's more than 3 and 1/10, but less than 3 and 2/10, and it's pretty close to halfway between those values. If I continue to split the space between 3 and 1/10 and 3 and 2/10 into 10 pieces, then I can see that this number lies between 3 and 15 hundredths and 3 and 16 hundredths. When I split the space between these values again into 10 pieces, this number will lie 8/10 of the way between those two values. But 8/10 of the way between 3 and 15 hundredths and 3 and 16 hundredths represents 8/1000ths of the total space between 3 and 4, because I split this space into 10 equal pieces 3 different times. I split the distance between 3 and 4 into tenths, then I split the distance between 3 and 1/10 and 3 and 2/10 into hundredths, then I split the distance between 3 and 15 hundredths and 3 and 16 hundredths into thousandths. So altogether, I have 3 and 158 thousandths, which can also be thought of as 3 and 15 hundredths and 8 thousandths, or as 3 and 1/10, 5 hundredths, and 8 thousandths. I could keep splitting the spaces between each number into 10 equal-sized pieces, and this can continue on into smaller and smaller pieces. This allows me to think of this number or any number in many different ways. From these examples, you can see that decimals use powers of 10 and extend the place value system to express values in between whole numbers. Once again, I'm Katie McCullough. Thanks for watching.